Hello and welcome to your midterm review for your Foundations 2 class at Amarillo College. I'm going to try to walk you through your midterm review. The first thing is to be sure that you print your midterm review sheet that's posted along with this video inside our Blackboard course. You will need to go through that sheet as your guide through this review video. It contains your testing dates, and if you haven't sent me an email already to reserve your date, time, and location that you wish to take your exam, these reservations are truly important. So I need to know when you plan to take your midterm exam and your final exam. On your midterm test, you will have some short answer questions. I need you to answer those in complete sentences because as future teachers, you need to communicate in complete sentences. These are the types of questions I'm going to ask you. What are the 7 ways to organize data? We talked about dot plots. We talked about stem and leaf, histogram, line graph, pie chart, bar graph, pictographs. All of those are in our textbook. And you need to tell me which types of graphs are best for representing categorical data. Now, categorical data is best represented by usually pie charts and bar graphs. Whereas, if you're representing large amounts of numeric data, that's usually best summarized by a histogram. Remember that histograms, the lines or the bars touch because they are intervals of numeric intervals that bunch up and touch next to each other, whereas the bar graphs, the bars do not touch. You need to be aware of that. Okay, the next thing we need to do is talk about section 13.2. What are 3 ways that we measure central tendency of data? That would be the mean, median, and mode. Be sure you know how to do those 3 things. What are 3 ways that we measure spread or variability? Well, that would be range, quartiles, and standard deviations. So you need to be able to just give a short definition of each of these. Those are found in the textbook. What are quartiles? They are the data points which divide a data set into fourths. These definitions are going to be important for your short answer questions. Be able to draw the normal distribution bell-shaped curve and be able to place the mean and standard deviation symbols for an entire population appropriately under this graph. So what does that look like? It looks like this. The mean for an entire population has the symbol of mu. So you need to be able to put that symbol under the center of your bell-shaped curve because that is where your average or mean is. Then, once you've calculated your standard deviations, you go up 1 standard deviation, which is mu plus 1 sigma. Sigma, remember, stands for standard deviation for an entire data set. So mu plus 2 sigma and then mu plus 3 sigma needs to go underneath 2 standard deviations and 3 standard deviations above the mean. Mu minus 1 sigma, mu minus 2 sigma, and mu minus 3 sigma are also to be placed underneath 1, 2, and 3 standard deviations below the mean. So you need to know this graphic that I just showed you here. Also, what does the 68, 95, 99.7 rule for normal distribution state? It states this right here. I'm not going to read it to you. You can pause and read this, but it is right out of the textbook. You do need to understand that 68% of the data falls 1 standard deviation above and below the mean. There's 68% of the entire data right here. 95% of the data falls within 2 standard deviations from above and below the mean, and then 99.7% of the data falls within 3 standard deviations of the mean, which is practically all the data in a normally distributed set of information. All right, so here are some example problems to study. I'm trying to hurry so that we know exactly how long this is recording. Good, we have about 10 more minutes. I have to keep it below 15. All right, the following is a list of ACT scores. So here I have just given you a list of ACT scores. Make a stem and leaf plot of the exam scores. So I'm going to show you how I do stem and leaf plots. This is important. Notice that we have only a few of the digit 1 numbers. Most of them are digit 2, and the other one have a tens digit of 3. So I'm just going to put 1, 2, and 3 as my stems. And then in order, I have a 0, an 8, an 8, and a 9. So I'm going to put 0, comma, 8, comma, 8, comma, 9 as my leaves off of the tens digit. Okay, then the hard part comes with the 20s digit. I can already get rid of the 30 also because there's just a 0 there. Okay, so that's taken care of. Next I need to do probably the 21. Okay, then I'm looking for any 22s. I don't see any. No 23s. We have a couple of 24s. Now notice I'm trying to line up my commas. This is very important, so you want to line these up. Okay, so we've gotten rid of the 24s. Now let's see how many 25 we have. 1, 2, 3 of those. And then 27 looks like the next one. 28. And then 2 29s. That is your stem and leaf plot. The way you can count to make sure that you have everything represented on your stem and leaf plot is to count your data points. 1, 2. We have 15 of these, so I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have them all represented in my stem and leaf plot. So that means that hopefully it's correct. Okay, let's go to our next one. Compute the mean, median, and mode for this set of exam scores. Hopefully you don't have much trouble with that. I already added these up, divided by 15. Earlier in my office, it's 23.4666. Now, finding the median is a whole nother ballgame. In order to do that, you have to list these in order. So, I'm trying to think if I have it listed in order somewhere. I think, yes, here they are listed in order. To find the median, I need to go to the very middle piece of data. Since there's 15 pieces of data, I'm going to count 7 in. 1, 2, 3, 4, 5, 6, 7. The very middle number, because there's 7 more on the other side here, this is called the median because it is the very middle data point of this data set. So my median is 25. Good. My mode is the piece of data that occurs the most. So as you can see, we have 3 25s here. I believe no other number is used more than 3 times. So that means that our mode on this particular problem is also 25. Okay, let's now compute the quartiles for this set of data. Once we find the median, and it happens to be our very middle number, this number is used up. And we now need to find the middle of these lower numbers. It would be 19 because there's 3 on this side of 19 and 3 numbers on this side. So 19 is what we call our QL, or our lower quartile number. 28 is our upper quartile number because it has 3 on either side of it. So there's our QL, 19. 28 is the upper quartile, and that's going to help us do our 5-number summary. Our 5-number summary has the QL, which is right here, 19. Our QU goes here. Our median goes here, which is 25. Our largest number is last. It's a 30. And our smallest number in the data set is 10. So it goes here. To compute our outlier boundaries, we have to know our QU and QL. We also have to know our interquartile range. So in order to get the interquartile range, which is what IQR stands for, we're going to take the QU, which is 28, and subtract the QL, which is 19. So 28 minus 19, I believe, is 10, I believe. No, that's 9. So that's going to make this different. I believe. So we may have to do some adjusting here. Okay. All right. Next, our outlier boundaries. I'm going to have to readjust this with my calculator. So to do our outlier boundaries, you take a QU plus 1.5 times the IQR, the interquartile range, which is going to be 9. So 29 plus 1.5 times 9, 42.5 is what I got on that one. Okay, for my upper boundary. Okay, that's my upper boundary. And then my lower boundary is going to be 19 minus 1.5 times 9. So I got 5.5 on that one. All right. And that is my lower boundary. Notice that none of our data set points are above 42.5, nor are they below 5.5. So there are no outliers in this set of data. Okay, last but not least, I'm going to try to find quickly, we only have 4 minutes left, so I'm really going to have to hurry. How do I find the standard deviation for this set? Well, we're going to use this formula, and we're going to take 3 squared plus 9 squared plus 5 squared plus 10 squared plus 4 squared, and we're going to divide that by 1, 2, 3, 4, 5, and then we're going to subtract the mean. And I'm not sure, but I think I found the mean earlier. Yes, the mean is 6.2 of this set. So 6.2 squared is going to be needed. So I'm going to take 6.2 squared. That's 38.44. That's going to be subtracted. Now I have to take 3 squared plus 9 squared. I'm doing this on my calculator, plus 5 squared plus 10 squared plus 4 squared. And I get the number 231. And when I divide that by 5, I'm going to get 46.2. Okay, so you take 46.2 and you subtract 38.44. And you get 7.76 under the square root. So sigma, which is the standard deviation for this set, is equal to the square root of 7.76, which is sigma equals 2.785, and you round it to the second decimal place, which is 2.79. And that is how you'd find the standard deviation for a set of data. So I hope I've been able to get everything done within the 15 minutes, and I hope this helps. Be sure to email me if you have any questions and need help with this. I'll be glad to go over things.